Welcome to January 2nd's LeetCode Challenge. Pairs of songs with total durations divisible by 60. You're given a list of songs where the ith song at duration of time t and I is in seconds. Return the number of pairs of songs which the total duration in seconds is divisible by 60. Formally, we want the number of indices I, j, such as I is less than j, with times I at plus time at j, where they take the modulus of that is equal to 0. So if you didn't get that from the examples here, you want to find two pairs of times that the sum of them are equal to the duration divisible by 60. So given this example here, we're given it a time with just an array, and the output is 3. Why is it 3? Because we have index 0 and index 2 right here, summing together give you a duration of 180, which is divisible by 3. By 60. You give an index 1 plus index 4, or 3 right here, which is sum of that gives you 120, which is also divisible by 60. And then you have duration of index 1 plus index 4, which gives you duration of 60, which is divisible by 60. Alright, and then we're given 3 60s here, so we have index 0 plus 1, that's 120. These two pairs make up something divisible by 60. Index 1 and index 2 gives you 120, which is all divisible by 60, and also index 0 and index 2, sum those two together, and you get 120 as well, which is divisible by 60. Alright, so you can make three pairs that have a duration of 120, which is divisible by 60, so the pairs themselves have to be distinct indexes, but they don't have to be distinct numbers. Our constraints. Alright. Let's see. Consider only the songs, modulus 60. Yep. Count the number of songs, length of 60 equal to r. Store that in an array of size 60. So that means, that from that, kind of getting like a lookup table of some sort. So we're going to have a lookup. And that's going to be a defaultdict. Alright, and then we're going to have our output, which is going to be incremented each time we count a pair. That's divisible by 60. Set that to 0. So for each time for each t in time, our output's going to be incremented 1 by our lookup at our modulus 60. So we are going to want to find a negative number that is modulus of 60. So at time t, of t is modulus of 60. Alright. And then we want to update our lookup table at modulus 60, modulus 60. Because we're only concerned ourselves with the times that are divisible by 60. And that's going to be incremented by 1. Right, at this index, if that index t is a modulus of 60, then we have to increment it by 1, so don't go over and look at it again. Alright, and then we want to return our output. Let's run this code. Looks good. Alright, so just let me give you a little bit more brief explanation on this. For each time t in times, we want to check to see if the opposite remainder exists. So basically, if we have an output and we want to increment that output, we want to have the negative modulus, right? So if we're looking, for instance, give an example. So say we have time of 15, and we take the modulus of that with 60. That's going to give you 15. And we want to basically find if the number at time t is 15, the only way this number is going to be divisible if the pair itself is going to be 45, right? So therefore, negative 15 modulus 60 is equal to 45. Therefore, 15 plus 45 is equal to 60, and huzzah, divisible by 60. and therefore we have this negative t modulus 60 because we want to know if the other pair, if the pair itself, if the number itself, time itself does not equal to 60, we don't want to find this exists another pair that's going to be added to it to make it able to be divisible by 60. And that's pretty much it. Submit the code. Awesome. Time complexity is big O of n because you do a for loop for each time and time t for each t in time. Memory, it will be the size of our default dict, which is actually not being, which is constant time, constant memory space. Alright, there you go. Have a great day, guys.